This video will cover the Georgia Standards of Excellence 3 OA 9, which states that students will identify arithmetic patterns, including patterns in the addition table or multiplication table, and explain them using properties of operations. For example, observe that 4 times a number is always even, and explain why 4 times a number can be decomposed into 2 equal addends. Second grade students explored odd and even numbers by focusing on conceptual understanding of equal groups and partners. Students began to see odd and even patterns as they explored different quantities. The doubles facts, including adding an even to an even number, as well as adding an odd to an odd number, created even sums that could be divided into 2 equal groups with no leftovers. But adding an even number to an odd number could not be divided into 2 equal groups. According to Van de Waal, the number endings of 0, 2, 4, and 8 are only an interesting and useful pattern or observation and should not be used as the definition of an even number. In addition to exploring odd and even numbers, second grade students worked with skip counting patterns by counting by 5s, 10s, and 100s. This leads to success in third grade as students continue learning skip counting patterns. As students expand on patterns in third grade, it is important to follow the CRA approach. Students begin by developing conceptual understanding by understanding that there are patterns on hundreds charts, number lines, and addition and multiplication tables. They also understand that using patterns can help to master basic facts, while understanding that multiplying any number by an even number results in an even product, and understanding that multiplying 2 odd numbers results in an odd product. This leads then to more procedural and representational understanding, where students identify and model patterns on a hundreds chart, number line, and addition and multiplication tables. Lastly, students explain, apply, and use patterns to solve a variety of problems. To discover odd and even patterns on an addition and multiplication chart, students can use counters as they investigate sums and products. In the upcoming video, students will explain what they predicted and then discovered when exploring different multiplication scenarios. As students modeled with manipulatives and explored a multiplication chart, they recorded their investigations and began to see patterns with the products, which led them to understand why an odd or even product occurred.
Odd because you can't create 2 equal groups.
You always have something left over, don't you?
Even because you can make 2 equal groups.
What was your prediction when you multiply an odd times an even?
My prediction was an odd.
Was your prediction true?
No.
So what happens when you multiply an odd times an even?
The product is even.
What happens when you multiply even times an even number?
The product will be even.
In the next activity, students explored skip counting patterns on a hundreds chart. The patterns discovered by the students proved to be useful to develop fluency with multiplication facts. Understanding number patterns develops true number sense that allows students to be flexible thinkers that can solve a variety of problems when stumped by a fact that they do not know. If you know your doubles facts, or can skip count by 2, you can also multiply by 4 by simply doubling the product. That same pattern continues as you multiply by 8. You simply need to double the 4's fact.
Any other patterns when you multiply by 4 and 8?
All the products of 8 are also on the products of 4. If you don't know your 8s, you can double your 4s to get your 8.
Patterns do you notice when you multiply by 3 on the hundreds chart?
Well, every time you multiply an odd number with an odd number, you get an odd number. And every time you multiply an even number with an odd number, you get an even number. So the pattern is odd, even, odd, even, odd, even.
Patterns do you notice when you multiply by 9?
When you multiply by 9 times 1, it's 1 away from 10. And if you multiply by 9 times 2, it's 2 away from a group of 10. And it keeps continuing all the way to 9 times 9, which is 9 away from a group of 10.
In the 512 ants on Sullivan Street, a family gets ready for a picnic, but one ant sees them through a telescope and heads over for a bite to eat. Before long, 2 ants are on the scene, then 4, then 8, and so on. The number of ants keeps doubling and doubling until there are 512 ants at the feast. Minnie's Diner is another great story on doubling. The story opens the door for students to implement the standards of mathematical practice as they reason quantitatively, make sense of structure, and look for patterns. As the story unfolds, the McVeigh boys are hard at work, but they smell the food cooking at Minnie's Diner. The youngest boy went to the diner first and ordered the special. The older brother, who is twice the size as the younger brother, ordered double. This pattern continues as the bigger brother joins the youngest for lunch. As students continue to explore number relationships, they will discover ascending and descending patterns. This ascending pattern shows the rule of adding 1 to each subsequent number, while this descending pattern illustrates the rule of subtracting 2. In the following videos, students created both ascending and descending patterns while encouraging their classmates to guess their rule.
It is 1, 2, 4, 8, and 16.
Do y'all know what his rule is?
Yes.
Multiply by 2s.
How do you know?
I know by 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. And 8 times 2 is 16. My rule, my pattern is 30, 28, 26, 20, and 24, and 22.
His pattern is minus 2 because 30 minus 2 is 28. 28 minus 2 is 26. 26 minus 2 is 24. 24 minus 2 is 22.
After students have opportunities to explore a variety of simple patterns, students should also be exposed to more challenging and complex patterns where 2 or more consecutive terms are missing. The roll-a-rule game is also beneficial as students create patterns based off of a specific rule. Students can also apply rules through the use of function machines and input-output tables by analyzing number relationships and patterns. In the story 2 of Everything, a farmer finds a magic pot which doubles everything that he puts into it. The rules of the pot can change as students create their own input-output tables. In the following videos, students complete input-output tables by analyzing the ascending or descending patterns that they observe.
So if there are 2 bicycles, that means there are 4 wheels, and there's 3 bicycles, we have 6 wheels. What's the rule to find out how many wheels we would have for 5 bicycles?
Multiply by 2.
So how many wheels would there be when we multiply 5 times 2?
10.
So if we have 3 dogs, that would be 12 paws, or 1 dog, that would be 4 paws. What's the rule?
The rule would be, since each dog has 4 paws, it would be times 4, and 2 times 4 is 8.
So if 10 go in, but only 5 come out, and 2 go in, and only 1 come out, what is the rule?
They're taking half, so it's going to be dividing by 2.
So 6 divided by 2 equals
3.
For additional resources and tasks for 3 OA9, please visit Unit 3 in the Georgia Frameworks.